Now, winding up Chapter 10 in Section 7, this is closure now of logarithms, where we will work with equations based on all of the little pieces we've worked on so far. And then, of course, you're getting ready for your test. So with that in mind, let's go on. Our objectives are listed there. And let's look at properties now of real exponents. Just to get some background, we did a lot of this way back in 1103 as well, for those of you who took that. And any value to the 0 power is 1. Just a little review, never hurts. B to a negative exponent. To make this positive, we just bring it down to our denominator, where the sign of the exponent changes, and we get this. Now, if we are multiplying exponents, or multiplying variables whose bases are the same, we just add the exponents. In number 4, we're subtracting. Now, these are all the different properties. This is the property of the 0 exponent, the negative exponent. This is the property of the product of exponents. This is the quotient property, where we're subtracting. Now, this is the power property, where we're actually going to multiply. And we said also, remember, we're going to move that in front. We'll be getting to that. And then this is just an extension of this, where it applies to each of our factors inside the parenthesis. And here as well. Now, as we start to look at equations in which there are logs and exponents and things, take a look at example 1 here, or item 1. Here our bases are the same. So if that is true, we say our exponents would need to be true, if, again, it's in an equation. Now, here, if we see our exponents are true, x equals y, then our bases must be the same. So it's sort of the inverse of this. And if you have log base b of x equals log base b of y, then your x and y should equal each other. And the inverse of it is true, that if x equals y, then the log of base b of x equals the log base b of y. Okay? And here's some qualifiers. So, let's go on and see what we can do with this first equation. And you might say, which scenario does this fit into? Well, our bases are the same. So if that's true, then our exponents should equal each other. So we'll do it over here. X squared. And I'm going to transpose this to the other side, where it becomes a negative 6x. And this is minus 7. And we're going to equal that to 0. So I took a little shortcut here. I should have just this equals 6x, but I've transposed that 6x to this side so I can put it in standard form. So now what I do is, the only method we have for solving quadratic equations in our toolkit so far is factoring. And what will our signs be? Well, if our middle sign is negative, the outers would have to be a -7, the inners a +1. And then solving this, x plus 1 equals 0, or x minus 7 equals 0. So here we get x equals -1, or x equals 7. All right, so that one wasn't too bad. Let's take a look at what the book shows here. So they included this step, and then they transposed it, factored, and you get your answers. Okay, so again, you want to be labeling your example 1 and then part A. Now here is part B. Now as we look at this, this looks a little bit challenging here. So I hit the solution key in error. I didn't want to get there yet. Now here, definitely my bases are not the same. So you have to think about that for a moment. But I could actually modify these. So 8 is actually 2 to the 3rd power. I'll put that in parentheses there. And 4 is 2 to the 2nd power. And then this is 4 minus 2x. And this is x plus 2. Okay. So now I could use the power rule and get this exponent here integrated with this up here. So this would be 2. And then this 3 times this up here is going to be 12 minus 6x equals 2. And then multiply this, 2x plus 4. Okay. Well, that one was a little bit tricky here because we had to fiddle with this to get our same bases. And now that our bases are the same, we can just work with this part up here. So this gives us 12 minus 6x equals 2x plus 4. Now I'm going to take the negative 6x over to this side as a positive 6x, add it to my 2x, and get 8x. Subtract 4 from here, or transpose, and this gives me 8. And I get, divide both sides by 8, I get x equals 1. And that's what I would stick with here. Okay, and let's check this, because we haven't been checking things here. If x is 1 up here, we have this as 4, and this is a 1 here. We're going to subtract 2. So this will give us 8 to the second. And this is 1, so this is 4 to the third. 8 to the second is 64. 4 to the third is 64. So this checks. We've sort of moved away to showing that these checks work, but we'll need to be checking things here. All right, let's see what they have here. The bases are different. We said that. Okay. So you had to fiddle with it to get the bases to be the same. Now, if the bases are the same, you work with the exponents equaling each other, and you get x equals 1. Now, for example 2, we're solving exponential equations with different bases. Now, as per the instructions they're giving us, we can take the log of both sides. Let's write it over here. So the log of 10 3x equals the log of 2.1. Now, if you remember in section 5 of this, we said when we have an exponent, we could take this exponent and put it in front here. So now we get 3x log of base 10, or 10 I should say, equals the log of 2.1. Now, what we're going to do is now, in an earlier lesson, we said that when we did, this was log of base 10 here, that we're not writing, but the log of base 10 of 10, we said that this just became this over here. So this part here disappears. And this was in section 5 that we talked about this. Whenever something appeared in this fashion, if we had like natural log of e to the 4, that this just became the 4. And if this were a log of 10 to the 10, and this was 4 or whatever, this just became 4. So this is what we're using here, and they're not explaining that too well. But then on this side, it just becomes 3x. So now, to find the answer of what x would be, we're going to divide both sides by 3. Now this is not a log anymore. Because of this, the log part disappears. So we get x equals whatever this is on your calculator. And let me do it on mine to see what I get here. We'll follow it through. So there's our equation. We're going to take the log of both sides. Now, here's where it gets a little challenging, as I mentioned. This is log base 10 of 10, and there's the exponent. We said when we had this earlier that if we had natural log base e of e to some exponent here, this would just become the exponent. So this is what they're showing here. In this case, common log. It works the same. Common log 10 of 10 to the 3x. This would just become 3x. So this is the little tricky part. Where did it go from there to this? So now as we divide both sides by 3, not the log of 3, but just 3, clear this up here. Putting that, we get 0.1074. And again, these are approximations here. We're rounding to 4 decimal places. Okay, let's go on to letter B. Now, notice there's no way we can convert this so that our bases are the same. So we're going to take the log of both sides here. So we'll do log of base 6 to the x power equals log base, well, remember these are going to be natural logs here. Common logs of 18, like so. Now, before, when we saw this arrangement, this was a 10 and this was a 10. This just became the x. But now these aren't base, this is not a base 10 here. So again, we're going to move the x over there. And we're dealing with common logs, so we don't have to write the 10. And this will be the log of 18. So notice that little difference here to the previous example. So how would I possibly solve for x here? Well, I'll change color so you can see it a little better here. I'm going to divide both sides by the log of 6. Now, these cancel out on this side, the marvel of algebra, and then x will equal whatever this is. Now, in this case, we are dividing the log of 18 by the log of 6. So, let's take a look at this. So, the base is 6 here, not 10, or e. But we can solve by taking the log of both sides. And let's see here. Okay. Now notice the log part didn't cancel out. We had to keep it because it's not base 10. So when we divide the log of 18 by the log of 6, and by the way, you could have taken the natural log of this as well. Everything is the same except we use natural log. And again, this isn't base e here, so the natural log part doesn't cancel out. And the natural log of 18 divided by the natural log of 6 gives you the same answer, as you will see. There it is for logarithms, and here it is for natural logs. Which is a good thing to know. So again, take a moment. You're getting some notes. And the key to this, the tricky part would be in example A, the logarithm canceled out on the left side. Well, because it was base 10. But on this side, slide B here, it didn't cancel out. So note that. That's a really significant thing. And we're at 20 minutes, so I believe we're going to probably do this one in 2 parts, or maybe even 3. So we'll wind this one up.